Alright, as you can see, got a lot of parts sitting on the ground now. And the mill looks just a bit different. I'll turn this light off. Guess that helped a little bit. So that is the new motor installed. You can see it's sitting on an aluminum plate with some aluminum standoff, some tool steel braces down here that are bolted to the head. And this is just temporary so that I can try doing some test cuts, which I'll show you guys here in a minute. I have already done some, and spoiler alert, this thing is an animal. I'm crazy impressed with it. A couple things, if you saw my Instagram post you may have known this, but it appears that I may have to come up with a different solution than this single V-belt. It actually is working a lot better since I posted that last night. I added quite a bit more tension on this, and now I'm not getting slipping. What had happened was I was using a face mill, just trying some different depths facing this aluminum, and at one point I tried taking like 150,000 step, and it actually stalled, what I thought was stalled the motor, and then I kind of looked up and the belt was still spinning, but the pulley wasn't. So it was just slipping by and burning up the, and burning up the belt here. So I may have polished this groove a little bit too well, or I just had it too loose. But since I've tightened it, I've taken some beastly cuts with the shear hog, and this thing is just done fine. So that's 200, see if I can get you to focus, that's a 200,000th step right there that I took at, you guys will see it in a minute, I don't want to spoil it, but I am really happy with how this is working. So right now I just temporarily have the enclosure sitting here. I need to install. I ended up getting a braking resistor, so I have to just mount that on the inside of the enclosure. I have the control just set up on an extension, so I can hold this by the mill right now and just use it sort of externally, and that's working fine for right now. I won't do that permanently. This will be mounted to the side of the enclosure. But yeah, I hope you guys enjoy a little bit of test footage, or test cut footage, and then it is officially time to tear this whole thing apart and do the epoxy granite fill, put the struts on the sides here, and swap out to the servos instead of the stepper motors. And so far I would say that if I had to run it exactly as it is right now with no further upgrades, I think I would be just fine doing that. I did try running it up to 10,000 RPM. I'll show you a video of that. Maybe I'll insert that right here. Okay, this is probably going to get a little terrifying. So 120 Hertz, this is about 9,200 RPM. See, this is stock bearings, and I really don't know if I trust this, so I'm going to stand back a little bit. Actually going to be quite a bit behind the camera, and maybe we'll try pushing this to 10,000 RPM, just to see what these stock spindle bearings do. If they blow up in my face, I wouldn't be that surprised. So let's give it a shot. 120 Hertz, 9,100 RPM. And that was 10,000 RPM, or 133 Hertz on the motor. Interesting. So I did try running this at 10,000 RPM, and it did it. Unfortunately, the spindle bearings, these are the stock spindle bearings, they definitely are not going to handle 10,000 RPM. I ran them at 5,400 RPM for quite some time, just kind of trying to simulate what like a Tormach 1100 can run at, that 5,400, and I just want to take some test cuts so I could compare it to things I've seen for Tormachs. And it ran 5,400 RPM perfectly fine for quite a while. I tried 7,000 RPM, and that started getting warm in the spindle bearings, and I think that's probably about the upper limit. Is I'd be probably comfortable running this at 6,000 RPM continuously, but because I'm planning on getting 10,000, I'm going to swap all those spindle bearings out. But hope you guys enjoy this test footage, and just in case you were wondering, if you just wanted to upgrade the motor and leave everything else exactly as it is, you would have to install that spacer block that I made, but I think you could do it just like this. If you're happy with your setup the way it is, and you're happy with maybe 6,000 RPM, then I think you could get away with just putting a massive 5 horsepower motor on your machine, and this thing can cut. I got 12 cubic inches per minute material removal rate, and I was only at about just over a half, a little bit less than 2/3 of the load on the spindle. So this thing can really cut some material. I'm guessing I could push 20 cubic inches a minute, and it would be perfectly fine, assuming the rest of the machine could hold up. So that is awesome for a machine of this caliber. So maybe tomorrow I'll have the machine completely ripped down, and then it'll take me a couple days to pour and cure the epoxy granite, and then I'll start reassembling things. 0.1 inch depth of cut, 0.6 inch width of cut, 5,400 RPM. I'll start at about 30 inches a minute and work up. Inches a minute. 50 inches a minute. 60 inches a minute. 70. Damn. 70 inches a minute. 100 thou depth, 600 thou width of cut. I didn't grab a current reading, but that didn't even sound like it was breaking a sweat. This is the same 5,400 RPM, 70 inches a minute, 600 thou width of cut, and 100 thou depth of cut. We're going to grab a current reading this time. Dang, that's good. Okay, for this test, 600 thou width, 150 thou depth of cut, 5,400 RPM, and we're going to start off at, I don't know, 40 inches a minute. We'll see what we can do. Holy shit. Okay, so we are shooting for 10 inches per minute, or sorry, 10 cubic inches material removal rate. This is 200 thou depth of cut, 600 thou width of cut, and 5,400 RPM roughly. And we're going to see if we can get up to 80 inches a minute, which will be just about 10 cubic inches a minute. So we'll start out at 40, and I'll just slowly walk it in. Here we go. We're getting a little bit of chatter at 60 inches a minute. Looking over, that was about, sorry, I'm going to move it over for one more. 600 thou. Looks like we were about 2/3 on our load, so we'll try it again. See what 70 inches a minute does. And here we go, 80 inches a minute. Alright, that's 80 inches a minute at 600 thou width of cut, 200 thou depth of cut, and I was reading 9.3 amps for load, so that's about 2/3 of the spindle load. Think we can push it harder? 600 thou width of cut, 200 thou depth of cut, 5400 RPM, and let's try 90 inches a minute. Alright, we're going for 13.2 cubic inches a minute. This is 0.74, so basically full slot. Width of cut, 0.2 depth of cut, 5400 RPM, 90 inches a minute.